Hi everyone. Now the topic is deployment under architecture modeling. Previously we have discussed about component and component diagram that belongs to architecture modeling. Okay. So now the third topic of architecture modeling is deployment. The last topic of architecture modeling is deployment diagram. Now we are going to deployment. So what is a deployment? So running the nodes, running the devices using some files, source files, running all the devices using some source files is known as deployment. So running, so these processors and devices are nothing but their nodes, nothing but their nodes. This node is a physical element that exists at runtime. Actually, this node is a physical element, nothing but a processor, each node having some computational resources. It is having some memory, and also these since node is a processor, it is having some processing capability. So these nodes, we use these nodes to model the hardware, so model the topology of the hardware, which is nothing but architecture of a hardware, right? So to architecture software intensive system, to design the architecture of a system, generally we need to consider two things. One is logical view and physical view. On the logical side, we used to model the architecture of a system in terms of classes, interfaces, collaborations, interactions, state mission. In terms of physical view, we model the architecture of a system in terms of components and nodes. So generally, a node is a cube. A node is a cube. So node is nothing but a processor. Any devices or processor we represent in UML by using cube, right? So we also use stereotypes to represent stereotypes for representing these processors. So every node can be represented by using simple name. Here the CSCO node is represented by using simple name or by using extra compartment. Here, if you see the sales, this we have represented this node by using taking an extra compartment sales. This node contains the components source files, components which is nothing but source files pox.exe, contacts.exe. So a node and the components. So node and components are both are same, but there are some differences. So both having some similarities. Like so, the both nodes and components are participate in dependency, generalization, association relationships. So both may be nested. Both, so we can nest the components, or also, and also we can nest the node as well. So both node and components are participating in interactions. So now these are all the similarities of node and components. Then what are the dissimilarities of the node and component? So generally node is a, so the components are the things that execute a system, which means a components nothing but the software components, which is nothing but a source files. Source files are the things that execute the system, whereas node execute these source files. That's why nodes are things that execute components. Nodes will execute the components. Components are the things that execute the system. Components are nothing but source files that execute the system. Nodes contains these source files that execute these source files. So components are represents that physical packaging of logical elements, whereas nodes are physical deployment of components. So here the relationship between node and the component are represented by using dependency relationship. Here the node sales is depend on these two files like pos.exe and contact.exe. These files are nothing but the components. The sale node is dependent on these two files by using dependency relationship. So how we organize the nodes? So we organize the nodes in terms of uh, so similarly, we can organize the components in terms of packages. Here also nodes also represented using some packages. So and also we can organize components in terms of dependency, generalization, association, relationship. Here nodes also we can organize in terms of dependency, generalization, association, relationship. So these nodes are interconnected by using some connections like association. So these connections may be a wire, Ethernet cable, or any kind of lines. So these are represented. These nodes are communicated by using association. By so we can also model the indirect connections such as satellite link between processors. Also we can represent it by using association notations. So here these are the connections of various nodes. If you see all these nodes, server, KSCO, server, console, RAID from all these are interconnected by using association lines. These association lines is nothing but 10T Ethernet cable or RS-232 cable or any kind of cable are represented by using association. So these are what are the common modeling techniques of deployment. So in what way we use this deployment concept is, see, this deployment concept is used to model processors and devices. For example, in order to model a processor and devices, first of all we need to identify the computational elements, and we have to model these computational elements as node. So after identifying the node, we have to represent each node by using some stereotype, and we have to populate these nodes by using some relationships, and also we can also represent each node by using some attributes and operations. So this is an example for how to model processor and devices. Here the processor is a server and the devices are RAID form, console, KS code. These are all the devices interconnected connected to the processor by using some association, by using some cables like 10T Ethernet cable, RS-232 cable. So these cables are represented by using association lines. So this deployment diagram is also used as to model distribution of components. How we distribute the components in the node. The main use of the uses of this node is deployment is to model the distribution of components. How we distribute the source files, how we describe the components inside the node. This is the use of the deployment. So to model the distribution of components, first of all we need a node that allocates some memory. After identifying the node, so we have to connect each node by using some relationships like dependency, association, generalization, or or any notation. So then if possible we can take an additional compartment as well, to additional compartment to identify the to name the component. And also we can also make a black plane of a model these component as we also make these components as black plane of your model. This is an example of how to model distribution of components. Here the components are user.exe, admin.exe, config.exe, db admin.exe, itktstr.exe. These are all the components, whereas the nodes are ksco, which is having no object name, console, which is having some object, server, which is having s object, raid form, which is an anonymous object. These are the nodes. How these all nodes are connected by using some TT Ethernet cable and RS-232 cable, which is represented by using association lines. If you see this node, a server object, it contains some attributes like processing speed is equal to 300 megahertz and memory is equal to 128. So it is also contains some operations like db admin.exe, tkt.exe. That's it. Thank you.